Hello everyone, this is Arpit and I welcome you all to my presentation on MATLAB program to generate discrete time sequence of windows and to obtain magnitude spectrum. And then we have to calculate the main lobe, the side lobe, that is the attenuations in dB, the main lobe width and the main lobe width. Okay, so now let's move on to our code. We have done this experiment using MATLAB using a tool called guide that is available in MATLAB, okay, to generate the GUI of this program. So now let's move on to our code, the actual code. So this is our code. uh, so the first variable that is present is a equals to get handles dot edit one string. What it will do is the input that we are presenting in our this program, so the length of the filter is the input. This is the edit text box. Whatever value we mention there, it will be in the form of strings that will go to a variable. But as it is in the form of string, so we can't do any computation, right? So we have to change it from string to number format. That is being done by str to num, and that variable is getting stored in enum. Okay, then we have used the following windows: rectangular, triangular, Hanning, Hamming, Blackman, Nuttall, Blackman, Nuttall, Welch, Langlois, and cosine windows. Okay, so this is our code. What we have done is we have used radio buttons, and the best thing about these buttons are if one of them is selected, the others are unselected. So we are avoiding that no more than one window will be projected on the screen. So here goes our code. So if the buttons are selected, the value will be 1. So this is what we have represented in our programming format. So if get handles dot rect equals to 1, it means that if that button is selected, then it will execute that specified window. It will generate the rectangular window. For that rectangular window, we have computed the DTFT by using this formula. After computing the DTFT, we have found all the required parameters that we discussed. That is our attenuation, the main lobe, the main lobe width, and other parameters. Those parameters are then fed to the static text box. This is our static text box, main lobe width and everything that is written in the right hand side. And then axis. Axis selects the axis which you want to plot. Means we can see 3 plots are there, right? So we have selected which plot will be generated in which of these windows. This is the end of our code. Then similarly we have written else if statement for all the other windowing functions. So now let's have a demonstration of our program. First, okay, let's make the filter as something 15. Okay, so this is our rectangular function, rectangular window, and here is the DTFT of the rectangular window, and this is the magnitude spectrum. It's in logarithmic scale, and we can observe the output. The main lobe width is 0.4288, the transition bandwidth is 0.0199, the cutoff is 0.4, attenuation is in decibels, that is 30 dB, and main lobe is 54.161 dB. Okay, now let's move on to another window, triangular window. This is our triangular window. Next is Hanning window. Next, Hamming window. Next, Blackman window. Next, Nuttall window. Next is Blackman Nuttall window. Next is Welch window. Next is Langlois window. Next, the last one is the cosine window. Okay, so here we saw the outputs for all the windows. Okay, now let us select a window at random, say Hamming window. Okay, now let's check how the transition bandwidth varies with the length of the filter. Okay, So for 15 we see the transition bandwidth is 0.2991. Okay, now let's increase the length of the filter. Let's make it 20. So now the transition bandwidth decreases from 0.299 to 0.169. Okay, let's increase it more. Okay, now the transition bandwidth decreases to 0.079. If we go on further increasing, we will observe that the transition bandwidth goes on decreasing as the length of the filter increases. So the conclusion that we draw from this experiment is with the increase in length of filter, the transition bandwidth decreases. Okay, so this brings us towards the end of our experiment. I hope you liked my experiment. Thanks.